So I wanted to be an eye opener for you. Come out with the tool and die making as well as tool design. So we come out with the tool and die making. There are two words involved in this. One is a tool, another was a die. So what are the difference between these two? I hope you would have understood this terminology. So I just repeat, tool is a two-dimensional, die is a three-dimensional. So three-dimensionals, you are very well aware that the terminology is pertaining to the mold. When you say mold, and now today GTTC is molding you people, tool maker and tool designer. So that is one kind of molding people here. And mold is indirect operation. When the mold is closed, what happens we don't know. When you talk about the two dimension, you say the press tool, press component, which is visible to you. But three-dimensional mold, it is closed concept and the material is being inputted inside, and what comes out we don't know. Coming out, the part which is coming from the mold, it is entirely depending on your knowledge and what is the effort you have put. That is a tool designing concept what you have brought in. That is going to be a replica of a component in the mold. Molding process, which they have told me to brief. So this is a common phenomena. Starting from the injection molding, next is blow molding, another is extrusion molding, another is insert type of molding. So like that is go on. So one of the injection molding which you are familiar, that is also continuing with there is one, so it's a calendering. I don't know if you have heard about it, calendering. I wanted to give an example to you. You or your brothers or sisters in the family, you are putting a binding for the books, binding paper. Binding paper is coated with a plastic over a paper of the brown sheet. So how it is laminated? Overlapping of plastic material over a paper, it is laminated. So this is called what you are seeing in the bonding paper. This process is called calendering. Now I am asking a very simple question. That means you are not opening your eye and what is happening, what is surrounding you. This is what you have to improvise. It is also one of the molding process. That is nothing but the sandwich. Plastic and paper put together, and one side there will be a plastic material pouring, another side the paper will be rolled and it is rolled in between. It is cured. You can imagine one side is paper, other side hot material. When it passing through the roller, the hot material and the paper, how it is, so the heat combination, it is, how it is cooled. When you put water in the paper, what happens? It gets softened. So you can imagine the hot plastic is layered on the roller or paper, how it is retained originality. So this water, the water, it is a cooling process. Coolant is supplied in between the roller and it is keeping the room temperature. So the one side is a heat, another side is a cold. So both process is called a calendering. This is not a new technology. I have seen it in the 1970, 69, 78. Sorry, 69, yes. In this process still it is continuing. So are we coming back to this thing, the injection molding, see, there are very, very vast subject. It cannot be narrated in 1 hour, half an hour, or it is impossible there. Only I can tell you the overall picture, how the process is made. Can you tell me some item which is produced by extrusion? That extrusion is made using different type of material. One is PVC, right? Another one, polypropylene. See, the pipes which are manufactured, it has to sustain the temperature of minimum of 100 degrees. So you can insert the pipe underground or the external using the sunlight. So when the sunlight falls on the entire surface is going to change. So today, high resistant material being used so that the sunlight will not affect the shape of the component or decolor it. So again, that a different type of extrusion is in the process using the different type of application. Pipe fitting is another aspect. It is done underneath and the householding item. When you are using a pipe fit material, a chemical transfer, one place to another place, chemical transfer. So depending on the application, we select the material, do the extrusion. The extrusion process is going to be different depending on the material what required. I just mentioning it here. Who is the brain behind manufacturing pipes? One is the person who has got the material processing technique. Another thing is the person who is a designer come tool maker manufacturing die for the extrusion. The GTTC in the middle of the tool design, they should take you people to different industry, expose the technique which is being that is one of the disciplines. That's why you acquire a knowledge. The die designing for extrusion is different. The die designing for injection molding is different. The die designing for the thermoplastic is different. The thermosetting is different. So everyone has got basic theory behind it, application. So this, when you go to industry, you can know. That is what I am saying, that I hope you can do eye-opening exercise on it, observing the thing. Thermoforming, it is again combination of sheet molding. You are aware of the sheet molding? It's a molding process. So how the thickness, there is injection, where the orifice, the material comes out from the barrel. It is not the narrow sphere nozzle, but this nozzle is equal to the width of sheet, which is about 4 feet. The material is spread over. It is fed into the constant roller with the forward and backward operation. There that sheet gets forward, it is being cooled. Different thickness is being made. And you can make a heavy block, a thin shade. Thickness, lowest thickness you have come across in molding process, sheet molding. Anyone can guess what is the wall thickness of this bottle? This thickness of the bottle. Yeah, now I want you to say 0.3, 0.4, and can it be molded? No, you can say easily it's a blow molding. It is one more operation involved in this. Common man saying it's a blow molding component. But when you talk about the technical word, what you would say? This is injection blow molding. Injection blow molding then, this, the more is not like this. This actually 1/3 of the bottle size is being molded, injection molded, 1/3 of the plastic size volume. Then the neck, which is the thing, it is maintained, retained, and the remaining portion is blown. That's why it's called the injection blow molding. And the pre-stage, what is the name? It's called Parison. This Parison is again a people like you will have to be designed the Parison. It has got another theory behind it. A shape is given. The Parison designed people like you, and the blow such a ratio, it is designed by you people. Then the mold is made, and it is a continuous process, a rotational molding. It is called as a rotational mold. So injection blows mold, the neck is held, then the next warming of the parison, then it goes to the next stage, then it is heated again. Next stage is go to the next stage, it blown. When it is blown, it is again cooled, then being rejected. So many operations is there in the injection stage mold. That's what is called a injection stage mold. There is called a rotational molding. It is nothing, the mold will be rotating. The name itself is there, the mold will be rotating. So they put the material inside the mold, the whole mold is rotating, and it is being decided of the wall thickness of the tank, whatever it may be. The rotational molding, the mold will be revolved. When it is revolving, the material, same time the mold is heated. So inside, you imagine there is a pot which is there, you put a material, the whole thing is revolving, and same time the heat is applied. And another thing, it is transferred to other place where it is cooled. So call it as a rotational. When you say molding process different, one more extrusion molding I want to highlight. The conduit pipe is something where the combination of two materials being processed. One is electrical wire, cables. Cable will be having center material, aluminium or copper. Over and above, there is a rubber is being coated. Over and above, the insulation is there. The insulation is nothing but a plastic. So two different materials. So you just imagine the plastic, rubber material molding is there, and plastic material is there. All the three together is coming as a one unit. That's called a cap. So different material they are using it for different application. When you say very hard, that is a electrical application, means there will be two things involved. One is amps and voltage. So both should withstand the. So like that, the wire and combination of that, the extrusion is there. That means over again the calendering process which I have told you, wire will be passing through a one orifice. Over and above the rubber material being first. So first it is separated. Then it is taken to some other machine, because both are different, can't be done with the same machine. So here again we have to have one rubber extrusion technique. After that it was re-molded in the injection molding, the extrusion using a thermoplastic. So rubber, when you say, is it a thermoset material, thermoplastic material? Very simple explanation, layman. Therm means heat. When this heat is applied, the material is getting hardened. Thermoplastic means when the heat is applied, the material softens. So these are the main difference between the thermoset, thermoplastic material. So this you could have studied the starting of your career, tool and die making. Some of your whole thing is you have gone through the injection molding. Another thing is blow molding, extrusion molding, calendering process, then injection blow molding. So all these things are, you just had an idea, and also seen the examples what it is being meant for. You have been asked to make a thermoplastic injection molding and the process. The process, when you heat the material, there is a softening stage. So there are two units, main thing in injection molding. You have two different units. One is an injection unit. Injection unit consists of barrel, then a hopper. Hopper is meant for preheating the material. Then inside the barrel you have a screw. A screw rotates. When it is revolving position, it takes the material front of the screw, I showed it. When the cycle time comes here, it is injecting the material. Simple process. So there is one more very crucial part in the barrel, the tip. What is that called? Nozzle. So as a designer, what is the profile of the nozzle? You have a different type of nozzle. One is flat nozzle, another thing spherical nozzle. You have a fair idea about what will be the holes which are provided in the nozzle. Injection material which is coming out from nozzle. 3 and 4, these are all derived from the material with which it is being injected in the mold. You have seen that the mold machine in our own Bangalore, there are, we call it as a tonnage. These two words are coming. One is short weight, another one is a clamping force. So when you are designing the mold, what are as a designer, what you will be considering? A clamping force is common, because when you specify the molding machine, how do you specify? One is the tonnage, another one is short weight. And another one, when you say the clamping unit, the method of clamping on the mold, that is also derived. It's already incorporated in the molding machine plated. So both the tools are clamped on separately. Then the injection is used. Once each machine has got a specific volume in the term of weight, it is every time when the short weight is named, it is so much material is being injected in the mold. A very smallest maybe is 60 ton, even 30 ton, depending on the component what you are designing or called for. So 30 ton, 60 ton, 80 ton, 120 ton, 200 ton, 400 ton, 600 ton, 800 ton and 1000 tons. Every day of your life, there should be a eye opening. Nobody will open your eyes. Your mind should open your eyes. And by observation. This, why I am telling this point, when you are going to design the mold here, you are going to see short weight. What is the weight of the component? When you say the weight of the component, then you are going to make use of the fullest capacity of molding machine. Okay, when you are buying a machine, it is going to be decided by proprietor, who are the owner of the company, what is going to plan the production. Weightage, short weight and clamping tonnage, it is equally one to related. The heat which is generating to heat the material in the barrel. I mean, you know, you have seen the close look, what will be the cycle time. Weight of the component, weight of the screw, weight of the runner system. All pulled together is called the short weight. So when the short weight say about 50 grams, 60 grams, how many seconds is going to take injecting the material? And the injection time? 10 seconds. Yeah, okay. Only pertaining, I don't have any component right now to show you, but it is varies depending on the material and the thing. Another thing is, again the designer role comes here. Short weight and runner design, everything count on that. And you have a layout, there is a runner, gating and the component. There is one more item which are mold opening. Opening time, removal of the component, ejection of the component, and closing of the mold, all put together, it called the cycle time. So in 7 hours, 8 hours, 1 minute shift, what is the cycle time? One can produce in a 7 hour, 8 hours a day. That is also counting on. A component weighing about 70 grams get a cycle time of say 45 seconds. So how many shots can be produced in 8 hours?
640.
640. Okay, that could be correct. I am not saying that wrong. It means the awareness what is required on the mold designer, the starting of the, when the moment you open the layout to designing the mold. So these are the primary things one has to keep in mind. So the cycle time applies in such molding and blow molding, injection molding. Can we set a cycle time for a extruder? Yeah. Extruder cannot be designed as a cycle time because it's a continuous process. It's a continuous process. A calendering process. Again, it is a continuous process. Yes. Blow molding is a cycle time because every cycle starts. So you cannot derive a cycle time for the extrusion or whatever other process. So one is said that for 640 cycle per 8 hours.
Sir, out of product in cable wire.
Out of
Electric cable wire.
cable wire.
Cable.
This is called a parison. So once it is carried out, this portion is always kept the same thing, but this portion is blown out here. There again the configuration is designed by the expertise of a design of parison. The another roller. The wire is fed. So that the wire is fed. So this is the first is rubber sleeve. Next this rolled with the going into the another roller where the plastic is again once again there it is comes out with another here plastic for the rubber because you have a thermoset material over and over the plastic easily will adhere to the surface, it won't get peeled or it won't get melted. That is, the roller which is there, it is revolving in this direction and this will be in the opposite direction. But this will be, before that, this material which are there in the nozzle, you have a die. The die is very, very simple with something like a flange die. Inner, equal to the diameter of the wire, the hole is made and through that the material will be followed. There again you have the nozzle, you have a screw. It is a flat cylinder. Behind the cylinder barrel, the die plate will be fixed. Through that the plastic will be melted and it will be coating on that. There will be a cooling. Once it comes out, there are a lot of cooling barrels which will cool and the wire comes out from there. That is what is called. The simple representation I am saying, I am not able to give you complete picture of the thing, but the basic principle like that. That's what when I happen to go on a visit to execute that kind of industry, you will have a clear picture. But here, as a designer, why I am just want you to expose it to making the die for this execute. It is not a complicated die. When you say the type of the pipe, it always measured, designed as the outer diameter of it. Okay. When you say the pipe, there will be a vacuum. Vacuum is created to maintain the outer diameter of the pipe. Okay. So when you say you have a 2 dimension, isn't it? Pipe means that is 2 dimension. It is OD, it is ID. You will be wondering how that ID is maintained. Internal diameter, there is one small, in the inside thing, there will be a small diameter where that's what the round diameter, it is held a core pin equal to the diameter inner part of the size, the core pin which is held in between, and through that the taper, the 4 holes or 6 holes will be there depending on the size of the pipe. The material will be flowing through the pipe, and end there will be a small nozzle like thing, the diameter mandrel it is called, that through the mandrel the material will be flowing on the outside. But by vacuum, in this area, when he comes here, it will be a vacuum here. There will be a vacuum pressure created to maintain the size of the pipe. No deformation to take place. Immediately it is cooled in a cold water, so that the diameter is. The problem is PVC making pipe is not a problem, but when you are making it a rigid PVC, there is a problem. PVC, somebody said, there are 2 different type of material. One is the PVC, one thing is, another one is rigid PVC. Rigid PVC used for all pipe fitting, and PVC, some other soft material is vacuum button. That's all made in the when you press it, the air is evacuated, that it is held there. So in that PVC, soft PVC, there is 2 categories. One is the PVC, then rigid PVC. That's why designing of Parisian is something different, and you will not be able to visualize what will be the Parisian shape. It will be surprising to you. And there one should have a designing of experience designing of Paris. That's another tough task. Can you guess what is this material? Cloth or plastic?
Plastic. Cloth protects as plastic.
See, there are so many things you can learn from this. What is this one?
Sir, ಅದು polyethylene, ಅದು transparent material ಅದು.
This is a polystyrene.
Yes, sir. Polystyrene also.
Polystyrene, how do you test it? Throw it. Now, what the sound it makes noise? If it is a polystyrene, the moment you throw it out, it breaks. It will not break it. That is the one simple identification of your material. Somebody saying polystyrene. That means you don't know about the polystyrene quality. As a designer, you should be very, very aware in telling it. You know the difference? If it is a polystyrene, it will break at any moment. Why I thrown it? I know very well it won't break. Metal injection mold. It is a very simple component where we are using it at home. There is a 2 processes there. One is a metal extrusion, then metal injection. So it's very, very critical operation. Metallic injection molding. It is the process which, imagine from the process nothing is powder. A powder thing is being injected into the mold. So you know that this material will be very, very hard, and how it won't be any kind of the melting. Can it be possible? Melting is not possible. By actuation of specific injection pressure, and it is fed into the mold, and it is. Now if that is the case, what will be the status of the mold? It is nothing different. It is a kind of injection molding only, but it is something like You have to strengthen the mold. What should be the material at which the mold is being manufactured? Another thing, I was just introducing a tip for you from the metallic. What is the basic material being used for pressure die cast? What are the materials? Nothing but a different kind of aluminum. Aluminum material is melted in a separate chamber, then it is transferred to the chamber die, then it is hot press. That is a very forcefully it is injected into the material. You know that is a injection molding, the process there few seconds, somebody is saying 4 seconds, 5 seconds here. But the die casting, it will be a split second, maybe 0.8 millisecond. Such a shortest period it is being injected. The main thing is what is the melting temperature of the aluminum. Melting, the furnace at which the material is molded, the molten material is transferred to the die. It is not a cold chamber, it is a hot chamber. So that material is being forced into the pressure die casting. It should have mechanically quite strong to withstand the temperature. Normally, the hot temperature will induce into the die, that will develop a crack into the die. So the die, to increase the life of the die, should be well heat treated. When you heat treat that material on that H13, S11, that is a different process being manufactured and it is heat treated. That is, the die will be heat treated in a temperature at which that is a softening stage. Then suddenly it is cooled. One more operation is done is, should be quenched, the die should be quenched in the minus 70 degrees. Then only the pressure die casting will give life. How to create the minus 7 degrees? That is another process is there. So that developing point that is a 70 degree, minus 70 degree, you have to create a path. A path will be created and the die part after heat treatment that will be quenched. When the hot condition and the extreme hot condition and extreme cold condition, if it is heat treated, the die will be good for pressure die casting. So this phenomena, what is requisite, will be made for die should be manufactured for metal injection. So when you are working the powder materially and injecting into the material, the die should withstand the thermal shock. But due to the heat, the die should withstand. And which the material is being injected, that should also be made of high resistant material. It is something which you are using a powder technology. Not that suddenly we think about material injection. Metal injection, it's again the copper. All the metal cannot be processed in that particular. This metal injection and the pressure die casting goes face to face. But it has got a negative surface as well as positive. And all the component cannot be molded in the metal injection. Have you seen that metal injection? There are many companies manufacturing the metal injection. After designing, completing the tool design, you don't know, you will not be knowing which type of industry you are going to employ. Depending on the industry where you are going to employ, you have to pick up the same requirement, you have to develop yourself so that you will be suitable for the environment and this is what they want. Not that everybody, you are talking about the injection mold, it is not going to be your line of activity when you join a company. Depending on the company and nature of production, you are going to develop, you have to develop your skill and knowledge. That's why GTTC is giving you, most of all the subjects is being taught to you. But you will be employed in a different type of industries. What is the basic requirement of a designer? First of all, one thing, you will be able to measure the component. That means you will be able to use the general instrument, 3D measurement system. Yes, you need not know it, at least the principle area, how the coordinates are being set, how the component drawing is being derived. They will be able to give you a coordinate. From that you must understand the basic dimension of the product. So one requirement is measurement. You must know conventional using conventional instrument. Then other apparatus, what is you are going to see the unimaginable. Suppose you are going to employ a company where you want to make a product. So you want to do a modeling. It could be a metal, it could be an engine part, it could be a reverse engineering process. When you want to have a reverse engineering, very, very challenging job it is. Here, what are the operations involved in this one? You just imagine if you have a vernier caliper, you will know the diameter, this outer diameter and the body diameter. It can be made in two ways. One is a deep drawing, another one is a spinning operation. And this again the development, the cylindrical part. When you calculate, you can arrive there what will be the outer diameter disc. That's a blank. What should be the blank for this making the deep draw component? Because first you have to make a blank, then you will have to put it into the die, or you want to make it as a spinning operation on a spinning lathe, and this can be done with a simple method of spinning mandrel. If you don't know the spinning method, this can make as a deep drawing die. So all the material, what is this material? Stainless steel. That is as we call it as a plastic. As you know, there are so many varieties of plastic today. Okay, and this is a draw component. The metallic qualification, that is the specification, one should have a deep draw quality. The sheet metal, stainless steel, confining to deep drawing method. Then only the metal can flow. So this is called a deep draw cold storage, chemical resistant material. Then you will not use the deep draw. The deep qualities are different. And how this impression made here? What is this called? This is nothing but the beading. And beading, how it is made? Why it is required beading? Because the lid should go and rest onto the particular surface. And one more thing, this beading is given for a stopper. And this diameter, inner, outer diameter and the inner diameter has got some clearance. Reminding you that thing had a fits and tolerance. Fits and tolerance for tooling is different. Fits and tolerance for a container is different. This is nothing but a container. If you are very tight, you will not be able to use it. You have a different tolerance for metal as well as a different tolerance for plastic. There is a different tolerance for tooling. What you are talking about, the guide pillar and guide push which are designing on the mold, you say G6, G7. That is a slide fit is only required. But slide fit 0.1 also it will slide. 0.02 also it will slide. What is specific name in engineering drawing? S7, G6. So S7 refers to what? Bore side. G6 is a shaft. So similarly, this one is shaft, this is bore. So what happens to bring it to closer feeling? So what they have done, they have put they have opened out the ID, so that the OD is retained, suitable to this. When you go to shop, you will remove it and open it. If it is easily operable, then you will buy it. If it is very tight, then you will not be able to take it out. Select the piece. So that's why the tolerance for enclosure is different, tolerance for plastic is different, tolerance for mold path is different. Got it? So now you know this component might have been made in the deep draw or it would have made in a
ಸ್ಪಿನ್ನಿಂಗ್ ಆಪರೇಟರ್.
ಅಲ್ಲ, GTTC ಟೂಲ್ ಡಿಸೈನ್ ಹುಡುಗರನ್ನ ಇವತ್ತು ನಾನು ಮೀಟ್ ಮಾಡಿದ್ದು. ಹೈಲಿ ಸೋಫಿಸ್ಟಿಕೇಟೆಡ್ ಸೆಟಪ್ ಐ ಆಮ್ ಸೀಯಿಂಗ್ ಇಟ್ ಹಿಯರ್ ಇನ್ ದ GTTC ಹಿಸ್ಟ್ರಿ. ಈ ಥರ ಒಂದು ಸೆಟಪ್ ನಾನು ನೋಡಿಲ್ಲ. ಅವ್ರಿಗೆ ತುಂಬ ಅವಕಾಶ ಸಿಕ್ಕಿದೆ, ಆದ್ದರಿಂದ ಅವರಿಗೆ ಒಳ್ಳೆ ನಾಲೆಜ್ ಸಿಕ್ಕಿದೆ. ಓನ್ಲಿ ಥಿಂಗ್ ದೇ ಶುಡ್ ಪ್ರಾಕ್ಟೀಸ್ ಆ್ಯಂಡ್ ಬಿಕಮ್ ಎಕ್ಸ್ಪರ್ಟೈಸ್ ಆನ್ ದಟ್ ಫೀಲ್ಡ್. ದಟ್ ಈಸ್ ಮೈ ಟೈಮ್. 18 ಇಯರ್ಸಲ್ಲಿ GTTC ವರ್ಕ್ ಮಾಡಿದ್ದು. ಅದಕ್ಕಿಂತ ಇವತ್ತು ಐ ಆಮ್ ವೆರಿ ವೆರಿ ಪ್ರೌಡ್ ಆಫ್ ಗೆಟಿಂಗ್ ದಿಸ್ ಅವಾರ್ಡ್. ಸೊ ಐ ರಿಯಲಿ ಥ್ಯಾಂಕ್ ಯು ಆಲ್ ದಿ ಪೀಪಲ್, ಅವರ್ MD, ಅವರ್ ಅಸೋಸಿಯೇಟ್, ಅದರ್ ಎಸ್ಪೆಷಲಿ ಮಿಸ್ಟರ್ ಶ್ರೀಧರ್ ಈಸ್ ಅ ವೆರಿ ಅನ್ಸರ್. ನನಗೆ ಒಂದು ಬಿಗ್ ಅವಾರ್ಡ್ ಕೊಟ್ಟಿದ್ದಕ್ಕೆ ನಾನು ಗೊತ್ತಾಗ್ತಿದ್ದೀನಿ. ಸೊ ಐ ರಿಯಲಿ ಪ್ರೌಡ್ ಆಫ್ ದ ಸಿಚುವೇಶನ್ ಟುಡೇ. ವಾಟ್ ಐ ನಾಟ್ ಗಾಟ್ ಇನ್ 18 years, ಟುಡೇ ಐ ಫೀಲ್ ಪ್ರೌಡ್ ಆಫ್ ಇಟ್.